Hello and welcome to this Construct 3 demonstration on how to create a color picker. Here you see that we have a slider that goes from the left to the right and selecting a value from the UV circle. And this is a saturation and value picker which will change the value and the saturation of and the color you selected here in the color picker, in the UV circle, sorry. The result will be shown here at the bottom, and automatically you'll see that it is converted to an RGB value and HSV values, and also in hexadecimal. So you could also change something to the value here, for example, then we change it like that, or like that, and you can see that it automatically changes. So let's see how that works. Now the color picker has two objects, as you saw earlier. It's the UV scale and the SV scale. Now the UV scale, if you go here, you see it's a static object. You can double click it and you can see it's all the UV values, but actually the UV value is a circle. And I've went and looked for some examples like this one or like this one. You can see here it starts off with red and goes through the entire circle and ends up with red again. So you have to remember that that actually is a circular something. Then this SV canvas, it's called an SV canvas for saturation and value, is actually a canvas which will be filled at runtime and which will use to do a further selection for the saturation and the value. This is just a sprite tool which will be giving the color, and then there are the RGB value, which is just input values here to represent the numbers of the color, and where you can change the colors of the numbers, of the colors rather. So looking at the event sheet here, so on start of layout we just call two functions that will update the SV and pick the color. So what we'll do is we'll go and pick the colors, and this is this function. So update SV is actually updating this canvas here, this SV canvas. Now, what color picker will do, is actually we get the HSV value and RGB values from the color picker, and we do that using the Lerp function, and we set the H, the S, and the V global variables, which is defined here. The H for UV in a value of 0 to 360, and then the saturation a value to 0 to 100, and a value in a range of 0 to 100 as well. So how do we do that? We actually use the UV scale, which is this one here. This is the UV scale, and then there's also, it's pretty hard to see, I think, in this resolution, but there's this little thing here. You can see that is the UV selector, which will be dragging to the left and to the right, and it's those two that we'll be using. So if I double click the expression, you'll see that we use the X value of the UV scale, and if we go back to the UV scale and we go to the points, you can see that the X value, the origin point, is here at the left hand side. So that means that if we use the X coordinate, we will have the leftmost side of the UV scale. And then the second parameter in Lerp is the bounding box right, which is the rightmost point in the UV scale. And then what we are unlerping and unlinear extrapolating is the X value of the UV selector thing we are dragging around. So what this will do is actually, this is the reverse function of the Lerp function. I've got another video on my YouTube channel where I explain in detail what the Lerp function does, and actually this does the exact opposite. It will return a number of 0 to 1, actually a factor, and it will tell you, okay, between this value and this value here, and how many percentage am I between those two values. If this x value of the UE selector is 0, that means is, for example, 100 x value, and the UE scale also starts at 100, which means that the result of the unlerp function will be 0, because these two are the same. If this one is 500 and this one is 500 as well, it means that the selector is at the end of the UE scale, so the result will be 1. And everything in between will be a value between 0 and 1. Which means that if we multiply that by 360, because there are 360 degrees in a circle, of course, and we round that, we get the h value. So we do about the same here with the s value and the v value, but instead of using the UE selector, we use the SV canvas. And there also is something called an SV selector, which does a pretty similar thing, which is this little cross here. This is the SV collector, and the saturation value is starting from the bounding box right to the SV canvas x, and using the x coordinate of the SV selector times 100. And the same thing happens for the v, but it's from the bottom to the y coordinate, and also the y coordinate of the SV selector. So that's it. That's using the unlerp function to determine, based on the selectors, what the value is which is selected in the HSV values. And then we will calculate the RGB values. We will update the sprite at the bottom, so calculate these RGB values here at the right hand side. We update this color picker, and then we update the text inputs as well. So update SV, which is also called here on startup layout, as an update which will actually repaint the SV value for the selected hue. So whenever we change this hue right here, this canvas here will be repainted to reflect all of the saturation and values for the hue we selected here above. The way that happens is we need to first convert it to RGB values. So we need to have the H value here, the RGB value, the H value, which is something we calculated right here from the hue, and which is stored here in the global number H. We use that to convert it to RGB, HSV to RGB. And actually, if you see that correctly here, this is a script which is being called an inline script, and it's actually this inline script, color convert, and we see here HSB to RGB to HSV. This is the function which is button called, and which accepts three parameters in RGB. No, it's vice versa, of course, but HSV to RGB, this one here, which accepts three values, H, S, and V. And this is the values which are given. So the H value divided by 360, and then 1 and 1 for 100% saturation and 100% value. So we get the RGB values here, and this is done by using the runtime.global_sparse.h. This is the way to give a global variable defined here in the event sheet to a function or a script which is defined inside the JavaScript file. And what the function will do is it will get it will set the temp R, temp G, and temp B local variables, which are defined here by using the math.round and of the RGB 0, 1, and 2 values. RGB is here a structure which is returned, which has three values in it: the R, the G, and the B values, which is returned by this function, and the first entry is R, the second entry is the B, G, and the third entry is the B. That's what it does. So then once we got that, the temp R, temp G, temp B, we use it actually to clear the canvas, and when we use the action to clear a canvas, you can also pass along a certain color with which it should be cleared. And that's what we're going to do, and we're going to use the RGB_X255 function to create a color based on the RGB values we got in those local variables. And then some interesting stuff happens. We can actually also put a linear gradient on the canvas. And there's two linear gradients which are going to be added. And in order to let me just undo these things here. In order to show you what it does, I'm just going to comment them, and I will comment them both. And you'll see that it's just a plain color. I will uncomment the first one, and you'll see that there's a linear gradient keeping the color, but adjusting the saturation of that color from full color to full white in a range from left to right. And that's what we just did here. We created a linear gradient in a box, left, top, right, bottom, and the first color is no alpha, and the right color is full alpha. So from no color to 100% alpha, and we do that horizontally. And the second one, if you see it, does also a gradient, but from the top to the bottom, going from normal saturation to full saturation, which is totally black. And that's done also with the linear gradient from with no color at all, from 0 alpha to 100 alpha. So actually that's superimposed on that, which will result in the result we're seeing right now. The only thing which is pure red, so pure, the hue selector is the top left here, and everything will be a value becoming lighter towards the right hand side and becoming very dark towards the bottom. That's how this works. So the update sprite function is very simple. It's just sets the color of that sprite to a color based on the RGB global variables. So you can just set the color of a sprite, and as long as it's a white background, it will express that exact color. If you use a colored background, it will mingle those colors, it won't be correct. So also there is some interaction going on, of course. When we click with the mouse button on the UE scale, we will set the UE selector is dragging to 1, which is a local it's an instance variable rather of the UE selector. And once we're dragging and the left mouse button is down, we will set the X coordinate of that UE selector. So in order to avoid going too far to the left and too far to the right, we're just going to set the X coordinate using the clamp function. The first parameter is the actual value we're giving it, as the actual value of the X, but the second and the third parameter are like the leftmost box and the rightmost value of that destination value, so it won't go below this and won't go beyond this. And then after we do that, we automatically update the SV and the big color. So the two functions which we just explained are being called again while we're dragging actually. Then once we click with the left mouse button on the SV canvas, we will also set the is dragging of the SV selector this time. And if we're dragging this, we set the position of that SV selector again using the clamp functions to not go beyond the X and Y and top and so the bottom left and the top right coordinates of that canvas. And then we pick the color. And we're finished dragging. So just set the is dragging instance variables of the two selectors to 0 when the left mouse button is released. And then there are some conversion functions which are used throughout this this application. Calculating as HSV will set the HS and V values and the global variables to a value based on the RGB, and this is used again in a script that uses a function in the color convert JavaScript file. Pass along the RGB values again and get the HSV values, and vice versa. Pass along the HSV values here and get the RGB values. That's exactly the thing I explained to you before, but using two other functions. So then there's the text inputs. As you remember, you can also enter text, but since there's no unfocused event in construct, we're tracking which color input object last had focus and then lost it. As soon as it loses it, we assume that the text has changed and we update all the color values. So if the color input that was being edited no longer has focused, we set this value last edit input to nothing, to good code, and then we call the text input updated based on the color input code. So if you have the color input, let's search for it here, this one. It has an instance variable code, and each of these values here has a different code. You see, code S, code V, etc. So that's how we discern the text inputs. So whenever we get focus and it's not the last edited input, we set the last edited input. So we're tracking, actually, we're focusing one of the color inputs, and then this happens, and then we track, okay, just this one is just being focused. When it's losing focus, yeah, and we check, okay, is it the one we were just in? Okay, then we're going to update it. Pressing enter inside the color input also unfocuses it, so it also calls this one. So the text input updated, then we're going to check, we pass along the code, of course, the code of the text input that was updated, and then depending on that code, other stuff will happen. So if we're changing the RGB values, we're going to get the RGB values from the text box. So here, something interesting here, we use object indexing here. There's a separate video on that on my YouTube channel on exactly what it is, but just remember we're selecting the first color input here, the one with the ID 0, and we're getting that text, we're clamping it from 0 to 255, and we're converting it to an integer. And we do exactly the same for the G and the B values from another color input, of course. And then we calculate the HSV, which we'll call this function here, and also set the H, the S, and the V values for us. Then if we're entering an hexadecimal value, then we will use a function, an expression from the browser plugin to execute one line of JavaScript. And the one line of JavaScript is here between quotes, and it will use the parseInt function to convert the hexadecimal value here in a 16-based number format to this variable call, which is a number. So it will convert this text to a number, and then we check if the value was okay, and this is a very neat trick. We just assign it to itself, and if that gives an error, it will assign 0, and if that it does not, it will just leave it at the call. And then we again see if the call is between 0 and this number, which is the maximum value, and so it will, if it's less than 0, it will become 0. If it's larger than this value, it will become this value. and then we use this neat little tricks, division by this number to become the R value, division by 265, remainder 265 for G, and then call remainder 265 for the B, and then again calculate the HSV value. But else means that we've just changed one of the H, S, and V values. We do exactly the same here, setting the H, S, and V values based on their color inputs, and then calculate the RGB from the RGB, so vice versa. And once all that is done, we update the text inputs and we update the color picker as well. So updating the color picker means that the Huey is set, and the Huey selector is set to the correct position. Yeah? And the X position of the Huey selector is again set to the H value divided by 360. Remember, it's a circle. And then we update that SV. Then we set the SV selector as well, and we do that using the Lerp function again, using the Lerp from bounding box right to X, S divided by 100. So remember, S is a value between 0 and 100. By defining it, we get this a value between 0 and 1, and then we just get the exact coordinate from these two here and put them in between, depending on the factor we get here in the third parameter. So remember, there's also a video on the Lerp function in my YouTube channel. Be sure to check that out if you want more details on how this works exactly. And then what we do here with the update text inputs, actually what happens is we set the text of these the color inputs to, if the code is R, then we set the R. If the code is G, then we set the G. We only use one action to do all of the other color inputs except for the hex color input. And for the hex color input, we can use the browser.exec.js JavaScript function, which we'll call here, and then convert it to a string with 16-bit which will mean that what we're passing along is a number in the 16 base number system, and we'll use that to set this text value. So that's it, and that's how a color picker works. I hope you learned something. As always, please like and subscribe, and I'll leave a link in the description where you can get this template. See you next time.